Okay, Melody, please let me know if you can see my screen.
Yes, ma'am.
All right. So we'll be continuing from where we stopped the last time. Melody, I was asking if the class we had on this practical topic, the practical you had today, was it helpful to you during your exam or
Yes, ma'am.
okay? So I'm taking from that you the examination was not difficult.
Not at all, ma'am.
All right, not at all. That's a good feedback. Okay, the last time we talked about equilibrium, right? And we established certain things that will help us understand or know how to answer some questions in equilibrium. And I made mention that some factors that affect equilibrium, okay, or some factors that we cause equilibrium shift is we have temperature, we have pressure, okay, also volume, and we also have concentration. Now, this would affect or disturb equilibrium, causing a shift. Okay, they all disturb equilibrium, and but then I said among these, it is only temperature that changes equilibrium, and I gave an analogy to explain this. That changes equilibrium constant. Equilibrium. So one of the things we didn't really okay, we also talked about how when when you're adding to a system, okay, equilibrium moves away from that point you're considering. So if you are considering it in terms of temperature, when you are adding temperature, equilibrium moves away from the side where the heat is. But when you are removing temperature, equilibrium moves towards the side where the heat is. Then in terms of pressure, if you are adding pressure or increasing pressure, the same thing with the temperature, either use the word add or increase, or use the word reduce or remove. If you are adding pressure, equilibrium moves away. Remember I said we consider pressure kind of in terms of number of molecules. Okay, so if we're adding pressure, equilibrium moves away from the side with more number of molecules. But if you are removing or reducing pressure, equilibrium moves towards the side with more number of molecules. And the same thing in terms of volume. And I said there is an inverse proportionality between pressure and volume, and there is a direct proportionality between pressure and number of molecules. So that is why when pressure is increasing, number of molecules is following suit. So that's why they are like they're directly related. Okay. So these are like the things we talked about the last time. So when we talk about equilibrium constant, equilibrium constant is it's numerically written like this, or like symbolically rather written like this. It is a numerical value that expresses the ratio of product concentration to reactant concentration. Okay. Also, yeah, I forgot to mention. We also mentioned that when we are going um the forward reaction, which is denoted by this arrow, it means that equilibrium is pushing or shifting to the right. Okay, and it means that it's going to the side with more, with increased, or rather more product and less reactant. And then the backward process would mean we have more reactant and less product. So an easy way to kind of remember this thing is to think of it like a normal reaction is reactant to product, right? So that is to say, reactants will highly react to give us product highly. So you see the arrow is going towards the side where product is. So when we are going to the right, we are forming the more product, right? And it will consequently mean there will be less reactant here. And then if we are going towards the left, just as we can see like this, the left has to do with where the reactants are found, right? So there will be more reactants, and consequently, like by the reverse, we'll have the less product. Okay, so back to what I was saying, equilibrium. So it is the ratio of the product of concentration to that of reactants. Sorry, the ratio of product concentration to reactant concentration. So it is denoted by K with a small c, is equilibrium constant. Okay. So for example, if we have an equation, a chemical equation like let's say A. No, let me not use this. Okay, let me see the question we have in this. Okay, it wasn't any actual question. Okay, so let us say we have this. Okay, iodine, hydrogen plus iodine to give us our forward and backward. Okay, we have this equilibrium equation. Now we said that equilibrium constant is the ratio of the product concentration to reactant concentration. So to write a equilibrium constant for this reaction, it would be Kc equals to, we write the product. The product here is Hi, hydrogen iodide. Okay, and then this bracket represents concentration, and then this two will now be written as a power. So this is now, as we can see this here, it refers to um concentration, the bracket of hydrogen iodide, 2 of it. Okay, and then so at the end of the day, the power is given by the coefficient. So whatever coefficients are the numbers at the front. This is the coefficient here. We'll say, okay, in terms of pressure, also identified as the number of molecule. Okay, so these ones, since there is nothing written there, we already know it is 1, right? So we don't really necessarily have to write the 1 and at the top. And then remember we said it is the ratio of product to reactant. So you see that at the top we are starting with the product. So it's more like this ratio, then the concentration of hydrogen, and then concentration of iodine. So this would be it, right? So to properly write it, this ratio is now going to represent our division line, right? So it will now be this. So this is the equilibrium constant for this particular equation. Okay. So having said that, do you understand melody? So
Yes,
at the end
ma'am.
of the day, we ought to begin with the product at the top and the reactant at the bottom. We should be either in the gaseous or aqueous state. Now, if we have any product that is not gaseous, that is not written like this. So if we have solid or if we have liquid, we don't include them in the equilibrium equation. Okay, we don't involve it here. So based on this, can you tell me in this particular question you can see in the on the screen? What's the correct answer? Yes, this question. Can someone tell me what the answer would be? Just in case you can't see properly, this is X and this is Z plus B Q. So we have T M plus N R. So we are assuming everything here is orderly in the gaseous state. Okay. This question is, I think, 2023. So to rewrite this, this is X then C plus B Q. So the lowercase letters represents the coefficients, and the bigger letters, capital letters, represents the um, chemical itself. Yes, Melody, which of them is the correct answer?
D.
D, very good. Because the reactant is M and R, which are what we're having here, concentration of product, and then concentration of reactant. Now, how about this? Do I have that question here? Hmm, I'm looking for a particular question I saw earlier. Still on this equilibrium as this equilibrium constants. Okay, if I get it back, I would ask it. I really want to ask that particular question because it would. All right, so let's just move on since I didn't see the question. Okay, so the answer is C for that one. Now to refresh our minds about what we did in the last class. Okay, what if we have this? What if we have this? What do you think would be
Um,
our equilibrium constant? What would be our equilibrium constant here? For the first one, and then we have another one here. This is also aqueous plus our
you see how many make it?
yes, melody. Or who else is in the call? Winner.
Good evening, ma.
Good evening. So are you following us up to this point? Do you know what will be our equilibrium constant for the first and the second one?
I don't know, but I'm just following. Maybe later we understand.
Okay. Why did you come late? So I was saying that if we have an equation like this, an equilibrium equation like this, like the one you can see on your screen, okay, to determine the equilibrium constant, it will be equal to the product, okay? Equilibrium constant is written as Kc, and it is equal to the concentration of the product divided by the concentration of the reactant. Okay, so this bracket I said signifies concentration. So to write this is equal to now concentration of the product. This product here is hydrogen iodide H and I. So concentration of H and I. We don't include the coefficient inside. The coefficient will now be represented as a square here, right? So it's a coefficient that will be at the top here, and then divided all over, then the concentration of all the reactants. The reactants here is hydrogen and iodine. They're separate. So we have hydrogen molecule. You know, the coefficient here is like an invisible one, so we don't have to write it. Okay. And then also concentration of iodine molecule. So remember to write the two. All these numbers that are subscripts, numbers at the bottom, okay, they are not considered the numbers we would write at the top, okay, as power. Do you understand? So this that we write equilibrium
Yes, ma.
constant, and then I was saying it should be for gases. Okay, it should be for substances in their gaseous or aqueous state. So now if we are having any equation whereby either our reactant or product is either in the solid or liquid state, we don't include that in equilibrium equation. Okay, we don't include it in equilibrium equation. It must be either in um gaseous or aqueous state. So back to my question. So we have these two here, 1 and 2. Can you tell me what will now be the equation for what will be our equilibrium constant? Yes, anyone can answer actually.
I'm coming, ma.
Okay, someone else
Just a
can answer.
minute.
All right. So in order to not take much of our time, because we have less than 30 minutes more. Okay. So we see for the first one, we first take note of the state. We have, first of all, our equilibrium constant will be, we said, the ratio of product to reactant. So we are dealing with our product first. The product will be our numerator, will be at the top, and the reactant will be at the bottom. The left side is always the reactant side, and the right side is always the product side. Okay, so it means that okay, this will be gaseous. It means that our equilibrium constant for this will just be CO2. Why? Because this is solid and this is solid. They don't surface in writing our equilibrium constant, okay? And for the second one, this is in solid state, so we are eliminating it. And this also is in solid state. And mind you, whenever you're giving questions like this, and you are actually making use of real substances, real chemicals, you should ensure that your equation is balanced. It's not like this one that we dealt with just now. This one, we're using just alphabets. Okay, so they were just symbols. So we don't really necessarily have to be thinking, oh, is it balanced or not? But you have to ensure that your equation is balanced. Now, for the second one, we'll deal with the ones that are aqueous. So our constant will be zinc. Um, I'm hearing some noise in the background. Okay, so it will be concentration of zinc ion over the concentration of copper 2 plus ion. All right, remember this 2 is not the coefficient, so we won't be writing it here. We'll just write the whole thing. So it's more like from this reactant, you are going to just put your concentration like this. Then anything that is at the front of it will now turn into a power. So this is just it. Do you all understand? Do you both understand? Do you understand? Melody and Rina. Do you understand? Okay. So now we have this question, one of your previous year's questions. The first question is to state the Chatelain's principle. So who knows it? Someone should state it for us. We talked about this in the last class. So what does Chatelain's principle state? Okay, that is something you can easily get from your textbook, your notebook, or just from online. Now the next question says, consider the following reactions. Since no one is going to answer the first one, let's move over to the more serious questions. We have this equation, and they said we should deduce, given reasons, the condition for maximum yield of SO3. Okay, now that is what we have here as our product. And said if the reaction is exothermic in the forward direction. So we are now given the direction our equation is going to. So we would now focus on what happens, or what are the conditions that favors that direction. We're going to be putting into consideration. Now we are dealing with temperature. Okay, this time we are not okay, we won't even be dealing with only temperature, because they are asking us the conditions, okay, and conditions that affect the shift in equilibrium. We said what? We said pressure, we said temperature, we said concentration, okay, we said volume and so on, okay, even catalyst and so on. Okay, although catalyst doesn't affect shift, but it affects speed. Now, two good conditions that we can easily deduce from this question in terms of temperature. We can do something in terms of temperature. Why? Because the number of mole is visible here, number of molecules. And we said we remember the number of molecules is connected with pressure, right? And then in terms of temperature, we can also talk about the influence of temperature, because we can see heat change here, which is less than zero, telling us it is exothermic, right? So now we are considering the forward reaction that is going this way. That is what we are considering. So we would think what favors that forward reaction if we are considering pressure. Now, in terms of pressure to yield SO3, that is to say, um for our equilibrium to shift towards SO3, that is towards the product, it means that we would first consider which side our number of molecules is more. Here it is 2 plus 1, right? 2 from the SO2 and 1 from the oxygen. 2 number of mole and 1 number of mole. That's what I mean. And then in the product, it is 2. So here is 3 and here is 2. That means the number of mole is more in the reactant. And so if equilibrium is shifting or going towards the product side, as the question has told us, that the reaction is in the forward direction, it means that, remember we said um when we add pressure, it moves away from the side with more number of mole. But when we reduce pressure or decrease pressure, it moves towards the side with more number of mole. Now it is moving away from the side with more number of mole. Okay, that is now due to what? Is it increasing pressure or reducing pressure? Someone should tell me. what will cause the equilibrium to shift to the forward side, the forward direction? Is it increased
Increase
pressure
in
or
pressure.
increase in pressure? Right? Because that forward side is the side with less number of molecules. So it will move away from the one with more. So that's a very good one. What about in terms of temperature? In terms of temperature, we see that this is exothermic. It means that the temperature is at the product side, not the reactant side. And now, since this reaction is all about forward direction, as the question told us here, okay, so it means
Just
that
like
it
the
is, huh? Okay, it means that it is going towards the products, right? So I mean, it means that the heat is in the product, and if heat is in the product, the forward, the reaction is going towards the forward reaction, so it is going towards where the heat is. And what did we say? Reaction moving towards where the heat is. What does it imply? Is it increasing temperature or decreasing temperature?
Decreasing temperature.
Decreasing. Very good. I seen it. So towards is what? Decreasing or reducing. Away is um increasing or adding. Temperature or pressure is the same trend. Now the next is Melody and Winner. I hope the two of you on okay, Winner is not here. I hope the two of you understand. I hope Melody understands since Winner is not here. Okay. Now the next
yes, ma'am.
okay. Now the question you can see on the screen says what is meant by an equilibrium system? An equilibrium system is a closed system. Okay, I probably did not mention in the last class. It has to be a closed system because if it is an open system, okay, we will not be able to give account of heat, for example, in terms of temperature. The um trapping of heat, reducing of heat, increasing of heat, and things like that. Okay, so it has to for equilibrium to occur, it has to be in a closed system. Now, an equilibrium system is a closed system in which the rate of the forward reaction equals the rate of the reverse or backward reaction. Okay, so that is to say the concentration of the reactant and that of the
Come
product. You said?
I said to come again.
I should
Equilibrium
repeat?
system.
Okay. I said equilibrium system.
Yes, ma'am.
I said equilibrium system must be in a closed system. An equilibrium system it is a closed system in which the rate of the forward reaction and that of the backward reaction are equal. So in essence, they are just defining what we already know equilibrium is. They are defining that A plus B, forward and backward, equals to C plus D. That's just what they're saying. They're trying to say that in a closed system, the rate of A plus B forming C plus D, okay, is equal to the rate of C plus D forming A plus D again, reversely. So the rates are equal such that the total concentration here is equal. Sorry, the total concentration here and that here are both constant. Okay. So we said again, equilibrium system is a closed system in which the rate in which the reactant forms the the rate of the forward reaction, that is when the reactant form the product, is equal to the rate of the backward reaction, okay? Such that the concentration of reactants and product are constant. Now, next question. State the effect of increase in pressure on the equilibrium position of each of the following reaction. Now, increase in pressure for this first one. Let me see who is in the classroom. Winner, can you answer the first one for us? What would increase in pressure imply? Remember, anytime you are dealing with pressure, you go and look for the side with more number of concentration and you focus there. You compare every other thing based on that side. So Winner, tell us, what do you think? What will be the effect of increasing pressure in the first equation there? Yes, any other person can also try it out. But I want to hear from Winner. If another person has the answer, you can say it. What will be the effect of pressure on this first reaction? All right. So now that
Uh,
yes,
it will increase the yield of CO2.
yes, increasing no, like the question is asking what will be the effect of increasing the pressure.
Increasing.
So where with the okay, that's also correct. The equilibrium will shift to the right, okay, which will
Pressure
also mean
will
increasing the yield of
shift the
CO2.
equilibrium constant.
That is true. Yes. Now, how about the second one? This first one is just like the first question we answered now, right? This SO question. So, in terms of pressure, they're more like saying following the same trend and having the same system. The second one, what will be the effect of pressure?
No effect.
No effect. Very good. There will be no effect. Why? Because there is no difference in our number of molecules, and so there's no effect of pressure. We don't know where pressure will be moving towards. We don't know what will be yielding more. Okay. And then for the last one,
It will shift equilibrium position to the left.
very good. We shift to the left, right? Resulting in production of this more. So, all right. So the difference between a closed and an open system, just as we have said before, a closed system allows nothing to enter, nothing to leave, so that we can be able to really talk about how constant the concentration of reactant, the concentration of product is, right? So in a closed system, no matter um nothing enters, nothing leaves, okay? And so energy can be exchanged within the system, and then equilibrium will be established. But in an open system, Energy in form of heat usually, okay, can be allowed to enter or leave the system, and so we are not able to monitor, control, or maintain equilibrium. So that's the difference between the two of them. All right. So please, do you have any questions so far? Is there any question? And also, if you want us to talk about another topic in the next class, you can let me know now. What topic do you want us to learn the next class? Since you all probably don't have a question. What do you want us to learn in the next class? Melody, winner, golden, or you are very confident about chemistry and you really want us to like freestyle. You've learned all the topics and you really don't need to learn more. Winner, I'm waiting for you to finish thinking.
Nothing more.
Let's what?
There's nothing more to learn.
Let's see more what? Okay, I think Melody talked about stoichiometry the last time. So I can't really hear you clearly, Winner. So we'll probably be doing stoichiometry in the next class. Right? Is that fine? Okay. I also want to hear what Winner was saying. So let's see if if we can probably merge the two topics because we've dealt with stoichiometry before, so that we can maybe maximize the time. When is your chemistry um when is your chemistry essay exam, your written exam? Yes. When is your examination? And when I'm still waiting for what you were saying. You can type it in the chat if you're having issues responding. All right. Since no one has nothing to say, that is all today. I hope you all learned something. Yeah, the three of you, I hope you learned something today.
Yes, ma'am.
Goldie, Rina, Melody. Hello?
Yes, ma'am.
All right, okay. That will be all. Bye bye. See you next week.
Bye, ma. Baby, my love. Baby.